Let's go ahead and get started. My name is Greg Francis. I'll be instructing this 205 course, and not my first rodeo. I've been doing this for 23 years, and one of these years, I'm going to get it right. So we're just going to keep trying till I do. Physics 205, mechanics and fluids. We cover some foundational topics. Motion, forces, energy, momentum, buoyancy, rotational motion, and torque. Those are the topics of 205. Now, I wish I could say that this is the most exciting part of physics. Not so much. We're going to talk about blocks that are sliding down inclined planes, which are things I'm sure you've always been interested in. I just came from teaching two sections of 207. And in 207 we get to cover electric circuits, electricity and magnetism, voltage, music, waves. Lots of really fun topics. So I'm going to encourage you to keep interested in physics long enough to take that 207 class. But that 207 class builds on what we're doing here. On the very first day of class, they were doing 205 material. They were using everything that they learned in the 205 class. So we have to build this foundation. And so I'm going to try to help you do that. In this class, I'm going to have you working with your neighbor a lot. So while I hand out some information, would you please introduce yourself to your neighbor on either side and find out a little bit about them?
Chad? Yellow. No. Hi. Chad. Thanks.
Okay, now, some of you realize that you accidentally sat down next to people that you don't like. That's okay. On Friday, just move. If you come in on Friday and notice that the people that were around you are somewhere else, it's okay. Don't take it personally. I've got some announcements to start with. The first announcement is that if you want to change the section that you're in for your lab or for the lecture portion of the class, you need one of these add drop forms, but my signature is not required. In the physics department, they use a multicolored stamp, and Margaret in the physics office wields that power. She's in room 264. You go up the stairs, first door on the right. Margaret's the one behind the long desk, and she can take care of that. My second announcement, got a call this morning from Bridger Ski Resort. They are closed all season. You need to stay home and study. Why would I lie? There's a help center in the physics department. It's right around the corner from my office. Room 235 is the help center. And I'll give you more information about that as we get that staffed. Now, it's open pretty much 8 to 5 every day, but the people who are working there are volunteers. Now, what that means is that some of those people are really, really good at teaching, and some of them just volunteer. And so if you find that you go to that help center and the person that's helping you is using a lot of equations to explain it, or trying to use calculus, or just confusing you, what you need to do is just go at a different time when someone else is teaching. And if you stop by my office, I can give you recommendations. If it were me, I'd go whenever Chat was in the help center. He's an outstanding teacher. I'm going to spend today doing a little bit of bragging about this course. And I feel comfortable doing that because it's not my course. I teach the lecture portion, but it's a team that teaches this 205 course. I teach, as I said, the lecture, and then we have some very talented graduate students who help us in the laboratory portion of the class. We've taken that laboratory and turned it into what we call a tutorial experience. And I'll tell you more about that in a little bit. I've worked with all of these individuals except one, and have confidence in their ability to teach. Now, this tutorial experience requires that we have one instructor for every 7 students. And that's a lot of instructors. And so what I've done is I've invited some of the most talented undergraduates from previous classes to return to the class and help us teach in that tutorial. Now, if you find during the course of the semester that you like it, that you're enjoying it, and that you're actually good at it, well, maybe you might want to consider coming back and helping us teach in the future. We can either give you Physics 492 credit, or we can pay you for your work. Now, the textbook, let's get that out of the way. The textbook, I know, is not on the shelf, and that's my fault. And I'll fix it, okay? Let me tell you about this textbook. Years ago, many years ago, we were using Cutnell and Johnson, which is the most popular textbook used in this level of physics course. And it costs about $240. And my colleague and I, Jeff Adams and I, were team teaching the course, and we did not like their chapter on energy. And so I remember asking the students, please, don't read the chapter on energy. Don't read chapter 6. And our students surprised us with their answer. They said, well, sure, no problem. We didn't read chapter 5. We didn't read chapter 4. We didn't read chapter 3. There was so much in that book that didn't help them get ready for the exam that they weren't reading it. And so Jeff and I rewrote chapter 6, and then we decided we didn't like the chapter on forces, so we rewrote that chapter. And after a while, we'd rewritten all the chapters. And with every chapter, we had a very different philosophy than is used in most textbooks. What we did is we wrote the chapters short, and we wrote the chapters in a very easy conversational tone. And we imagined, every time we wrote a chapter, we imagined a student sitting in our office. And it's something that happens often. right before a midterm. A student sitting there and says, Greg, I don't get it. I've been to lecture, I've been to the tutorial, I did my homework. I just don't get it. And we asked ourselves, what would you do for that student? What picture would you paint for that student to help them see it? And that's how we tried to write each chapter. And a result, the chapters are short, the exercises are very pointed, so it's a very different book. Now, our colleague, Ron Hellings, approached us after we'd finished the book and asked if he could rewrite it for a national audience. And he's done that. And this last semester it's been field tested at different universities around the country. And we've got a publisher, it's going to be published, it's going to be on the shelves a year from today. And so that means that this semester and next semester are the last semesters that you can get it for the cheap. We only charge you for what it costs to print this. Now, I know it's not on the shelves. The reason for that is I went to Mexico. Anyway, I just got back last night. Anyway, before I left, I asked Ron to take care of this because I knew he wanted to make some changes, and then I just left the country. I didn't have internet anyway, and so after I left, Ron went to the hospital. He had some problems. He's going to be okay, but he was in the hospital for all the break, and so. When I got back from Mexico, I called the bookstore and they started shouting at me. They said, we don't have a book. And so what I've done, they'll have the book on the shelf by Friday. And in the meantime, I've posted the book, the first chapter that you'll need, I've posted at the D2L site. And I'll show you where you can get that in just a moment. So that's our textbook that we'll use for learning the physics. Now, there's this lab textbook, the tutorial book, and it comes in 2 volumes. These are the tutorials that you'll actually be working through during the lab time, and these are the homework assignments that are associated with that each tutorial. Now, I think that these are the best curricular materials in introductory physics that exist on the planet, bar none. And I'm a little biased on that. These were produced by Lillian McDermott's Physics Education Research Group. Now, her group, Lillian McDermott is the first person in the world to actually create the field of physics education research. And she was the first person to award a PhD in the field of physics for physics education research. Now, what she does, what her group does, is try to figure out, why is it so hard? Why is this so hard to learn? And I'll tell you why it's so hard to learn. Because you already know physics. You may get to college without knowing any chemistry or very much biology, but you cannot get to college without already understanding physics. Because you use tools, because you drive a car, because you live in a physical world. And if you're like everybody else, you taught yourself some physics that was wrong. Well, it's just not consistent. It doesn't fit together. And it turns out that learning is hard, but not nearly as hard as unlearning. If you're trying to unlearn something, that's difficult. And so that's what Lillian and her group have done with these materials, is she's written activities where she gets you running in a direction that you feel comfortable in. You think you know the right answer. You're sure you know the right answer. You're thinking this is so trivial. And then she just rams you into a brick wall and suddenly you got the wrong answer. And suddenly you got to piece back together your view of the world. Now, folks, that involves being wrong. But worse than that, it involves being wrong in public. That's a hard kind of wrong. Now, the only way we can survive this experience is if we agree to be friends. I mean, let's face it, you've done some stupid things in front of your friends, right? You still joke about it. Oh, you remember back in Mexico? Yeah, that's okay. If we agree that we're all going to be friends and we're all going to be wrong and it's going to be okay, we'll get through this. Okay? Now, these materials, I was part of a research group when we put these together for the first time. She had been working for years and years and years with high school teachers and elementary school teachers, training them. And then the physics department came to her and said, we need you to fix our engineers. And so we took all of that research, the 25 years of research, on all the different misconceptions that students struggled with, and we put this together. And Mark Summers and I were the first ones to take it into a classroom, and it was a wild experience. At the first of the week, we'd take the first version of the tutorial in and would come right back out and say, oh man, that third page, that didn't work at all. And so during lunch, we'd rewrite the third page. By the end of the week, it was a very different tutorial than the front of the week. And so what we have here have now settled down. We're happy with these tutorials, and I'm sure that they can be very effective in helping you learn. Now, the reading assignments are on this pink sheet that I gave you. Tells you what chapter we're going to be covering, what chapter you should be reading. And I would encourage you to read slowly. This is not a novel. You know, you got to realize that every example in every chapter is meant to uncover some difficulties. And so there's a lot of richness in those examples. You have to carefully go through them. Now, when I was your age, a million years ago, when I was a beginning student, I always went through every chapter 3 times. I read the chapter before it was lectured on. I read the chapter before I did the homework problems. And I read the chapter the night before the test on that chapter. But I was a geek. I had no social life, didn't talk to people. You'll have to decide what works for you. Okay? Now, the course website, let me show you. When you lose your yellow sheet, there it is. You can go back and get it. And when you lose your pink sheet, you can get that. More importantly, if you go down here, we're going to start with kinematics. And this is today's lecture. If you click on that, you get the PowerPoint that I'm going to use today in class. Now, it won't be available until after class is over at 4 o'clock. But the reason I do that is because I want you to be different people when you leave this room than when you came in. And research shows that taking notes doesn't do that. If you just write down everything I say, that does nothing for you. Okay? We need to have an experience. We need to solve problems. We need to argue. We need to have some give and take in order for you to change the way you look at the world around you. Now, because of that, I don't want you to be worried about getting everything down in your notes. So everything we do in class will be put up on the internet right after class is over with. Now, while I'm here, your homework solutions will be posted here. Right before each midterm, I'll give you sample exams and sample exam solutions to practice with. This section here, textbook and special problems, if you go there, there's chapter 3. Well, Greg, I was kind of hoping for chapter 1. Well, it turns out that chapter 1 is kind of, well, I'm not going to use the word boring, but it talks about science in general and, units, and it's the standard introductory chapter that's in every textbook. What we're going to start with is the chapter on vectors, because we're going to need that right away. And for reasons that I don't want to get into, that's back in chapter 3. That's the way most people cover it. They wait until chapter 3. I want to jump right into there, okay? And it used to be chapter 1 for me, but we're going to start with chapter 3. And if you click on that, you'll get the PDF. You're right there on chapter 3. And at the end of the chapter, you'll have the homework problems. Okay. Now, like I said, lecture, we want it to be a very interactive experience, and so we encourage you to be here. And we're going to actually take attendance using the clickers, the eye clickers. We hope that, today I'm doing most of the talking, but the hope is that I'll talk for 5 or 7 minutes, and then I'll get you working on a project, and you'll be working with your neighbors, and then I'll call us back together and we'll talk some more. I give pre-tests typically on Monday. And these pre-tests are very important to the learning process, and I use them 3 ways. The pre-tests are typically based on a question that I know many of you have a misconception about. For example, there's one of the pre-tests that we're going to take this semester. I've given it over and over and over again, and every time I get the same result. 95% of you get it wrong. But 100% of you think you've got it right. Okay? That's the genius of these pretests. Now, many of these pretests were written by Peter Schaefer, a dear friend of mine. I shared an office with him when I worked with Lillian McDermott. And it always, as he was developing the tutorials, he's the principal author of the tutorials. As he was developing them, he'd always try them out on me. I was his guinea pig. Greg, I want you to take a pretest. And I thought, oh, do I have to? Oh, man, I know I'm going to be wrong. Anyway, the first point is that it's going to help you recognize that you've got this misconception. Secondly, I have a lot of people that are teaching with me. I have a large teaching staff. And so if those people are not all teaching the same way, it's going to confuse you. It's going to frustrate you. So what I do is I bring them together every Tuesday morning for 2 hours, and we have a staff meeting. And the first thing I do at that staff meeting is I give them the same pretest that you took. And I look over their shoulder to make sure that they get it right. Okay? Because if they've got the misconception, I want to fix them right away. The next thing I do is I give them a great big stack of your pretests. And I have them read through those really quickly. And by doing that, they figure out what you're struggling with. And that's helpful. Our graduate students think that you're hung up on, you just don't get the calculus, or you have trouble with the equations. And that's not it. What we find is that many of you are struggling with the distinction between velocity and acceleration. And by reading your pretest, they get it through their head that, oh, this is what they're struggling with. This is what I need to help them fix. So it helps me train my staff. And then at the end of the week, after you've been through the tutorial, you will know what the right answer is to that pretest. And by knowing the right answer, and knowing that you didn't have the right answer on Monday, you will recognize growth. You will come to see that, oh, I see things differently than I used to. And that will, I think, motivate you to go on. Now, we often have demos that are life-threatening, okay? Just out of general interest. How many of you, raise your hand, how many of you are taking this class because you have to? It's required for your major. Yeah, everybody. Okay. I didn't believe for a second that you were here because you were just interested in physics, okay? It's just something that people tend to put off. And I feel an obligation as your instructor to try to make this class as interesting and as engaging as possible. And what I have learned over the years is that the closer the professor comes to death, the more you pay attention. And that's why I do demos like the Bed of Death. Okay? The Bed of Death, I can tell you even what day it's going to be on. It's going to be on March 25th, Impulse, Chapter 6. Bring popcorn, bring a friend. I'm going to lie upon the Bed of Death. We'll put the chest plate of death on my chest. We'll put the cinder block of death on the chest plate of death. And then the angel of death, one of you, will swing the sledgehammer of death, crushing the cinder block of death. Death all around. And if I live, we'll talk about impulse and momentum. If not, the semester's over. Now, I came upon this principle quite by accident. My first semester here, I was teaching the electricity class, and I went to what was then Montana Power, and I borrowed a great big transformer, because that's what we were talking about in class, and I was going to use that in one of my demos, and as I was hooking it up, instead of hooking it up to the wall, I hooked me up to the wall, and I just fried myself. I went home that night, I was so discouraged. I told my wife, oh, that was the worst lecture ever. I fried myself right in front of the class. 2 years later, I'm in Safeway. My old students came up to me and they said, oh, Dr. Franz, we just loved your demos. You know the one we liked the best? The one we liked the best, you were just frying yourself. I went, okay, that works. That's part of the lecture. Now, actually, one more story. I can't hear you without these hearing aids. I need these hearing aids because 5 years ago, I did a demo called the Exploding Capacitor. I've done this demo for years. I'm the only one in the department that's dumb enough to do it. But what I do is I take this great big capacitor bank and I charge it up till it's got 1,000 volts across it. And then I take a metal paddle and I put it across that and it makes a bang that you can hear 2 buildings over. Well, 5 years ago, I saw on the side of this capacitor that it could really go up to 3,000 volts before you destroy the capacitor. So I thought, why not? So it takes a while to charge up, so I put the people in the front row in charge of looking at the dial, and I said, tell me when it gets to 2,000 volts. We'll go to 2,000. Well, they got involved in the lecture, and finally one student's waving his hand, and he says, Dr. Franz, 2,700. So it got up to 2,700. Fool that I am, with a smile on my face, I'm right next to it, and I popped this thing. And I couldn't hear anything for 24 hours, which was kind of nice, because my wife said some things, I'm sure, that I never heard. But what I forgot, in my enthusiasm for making the class fun, I forgot that the energy stored in a capacitor goes as the voltage squared. So even though I only had 2.5 times or 3 times the amount of voltage, I had about 10 times the amount of energy. And I was standing right next to it. Dumb, 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 dumb. That's not to say we're not going to do dumb things, if it helps the class. Okay, what is a tutorial? In a tutorial, we have small groups, and we have an instructor working with those groups. And if that instructor gives you answers, they failed. If that instructor lectures, they failed. What they're supposed to do is have a Socratic dialogue with you, where they ask you questions to get you to develop the key ideas of physics for yourselves, to build the physics so that you own it. Okay? Now, again, it could be a frustrating process, but if we agree to be friends, we'll get through it. Now, this is a very old picture. These 4 are pretending to be students, but they were peer instructors of mine. Michelle, one of my very first graduate students, is playing the part of the instructor. This is Kevin Wolverton. He's now a very prominent doctor at the Mayo Clinic. But this is the person I really want to tell you about. Michelle Larson, last spring, became the CEO of the Adler Planetarium in Chicago. That makes her the very first female director of a major planetarium in the United States in the history of the United States. And she was an undergraduate at MSU and a graduate student at MSU. We're very proud of her. She's good. Okay. These tutorial materials find that there are a lot of teaching styles that go under the name of inquiry. Some teachers put equipment in the middle of the room and tell the students, go at it. And it's just chaos. When Lillian McDermott talks about inquiry, it's very, very guided inquiry. And by that I mean it feels almost like this little, she's only this tall. And she's got a lot of energy. It feels like she reaches up your nose, grabs your nose hair, and she's dragging you to the answer. Okay, that's the way you're going to feel sometimes. And she's thought through her group has thought through every single part of this tutorial. Now you're going to think that some of the parts of the tutorial sound poorly written. And that's by design. What? Think about it. Most of the people in the tutorial are going to have a misconception. They're going to be thinking the wrong thing. Some of the people in the room have figured it out and have the right model of the universe. You're going to have to write this tutorial so that it makes sense to both groups and it doesn't give the answer away to the people that are trying to work through the misconception. It's a very difficult thing to write, but Lillian and her group have done a wonderful job of doing it. Okay, again, based on 25 years of careful research, pre-test, post-test, interviews with students. Now, homework comes in two flavors. When we started out with the tutorials, we collected the worksheets and graded them. That was a mistake. It turns out that the engineers that were doing the tutorials were so worried about getting the right answers and getting their grade that they wouldn't talk to anyone in their group. It destroyed the dynamic. So now what we do is, this tutorial is your property. You can write a lot in it or nothing at all. We'll never collect it. The second volume of the set has a tutorial homework for each one of the tutorials. This homework assignment is written in such a way that if you really went through the tutorial like you should have, it'll be easy. You'll sail right through it. If you didn't pay attention in the tutorial, if you let the others in your group do the work, if you let them do the thinking, you really don't have much hope of getting the right answer. Okay? And this is how we grade the tutorial portion of the class, is with the homework assignment. It's due the following Tuesday. You'll turn it in on the second level of this building in the atrium, and I'll give you more instructions when we get close to that time. Like Calvin and Hobbes, I don't think the schools assign enough homework. We have a second kind of homework. In the textbook that you haven't bought because it's not in the bookstore, at the end of every chapter, there are problems. And every lecture, I will assign 3 of those problems for the next lecture. Now, what you will do is you're going to go out and invest in a bunch of 5x7 cards. And on Friday, you're going to show up with 3 of these cards. And 1 card for each of the 3 problems that you've been assigned. I'm going to let you vote one of those problems off the island with your clicker. Say, we don't want to turn that one in. That was ugly. And then I'll flip a coin to see which of the other 2 we turn in. And we only have enough grading staff to grade one of the three problems. Now, I know that we're all busy people with busy schedules. And we're going here and there. And I don't want to, with 600 students, I don't want to have to deal with all of those contingencies. So what I'm going to do is I'm going to let you drop your 4 lowest scores. That means you don't have to turn in homework. And it won't affect your grade at all. Just don't turn in homework 4 times. It won't affect your grade at all. I'll also let you turn in homework late. By late, I mean till 5 o'clock, 6 o'clock that evening. There's an envelope outside my door. Just put your homework in there. Full credit. Twice. The 3rd time you put your homework in that envelope, I'll just throw it away. Okay? And that's the way we'll deal with missing homework and late homework. Now, there's the first homework assignment. It's in chapter 3. Problems 1, 2, and 3. Chapter 3 starts with a brief review of trigonometry. And these 3 problems are just very basic trig problems. Very, very slow start, easy beginning. They'll get harder. Trust me. Now I've been rambling on. Are there any questions? Have I left you feeling confused and dizzy? I'm rambling like this because I'm nervous. You people scare me, okay? I love teaching. I love lecturing. But I don't enjoy doing it to strangers, okay? And so by the time when I get to know you and love you, this will be very easy for me. But the first day of class, I'm up here trying not to throw up, okay? The 207 class, that was fine because I knew all of them. That was fine. So just please come visit me, introduce yourself. Let's get to know each other so I'm not so nervous. Okay, exams. We're going to have 3 midterms. I'm going to write them so that they can be done in 1 hour, but I'm going to give you 1 hour and 50 minutes. So you'll start at 6 o'clock, you'll have until 7:50, and that way we try to take the pressure off, the time aspect of the exam. I try to minimize. Now, a quarter of that, each of those exams will be multiple choice, but 3/4 of each exam will be explain your reasoning. And so if there's a problem worth 5 points, and you get the right answer and you circle it, that'll be worth 2 of the 5 points. And the other 3 points will be for your reasoning. Did you show your work? Did you justify your answer? Speaking of justifying your work, explain Newton's first law in your own words. Yakamagog, grog, zik. I love loopholes. I didn't say it was funny, it just applies. Okay. The final exam is sort of cumulative. 2/3 of it will be on the new material that we've covered since the last midterm. And 1/3 of it will be an overview of the whole class. Now here's the thing, with physics, everything we do builds on what we've done, where we've been. It's like a house of cards. And so by the time we get to that final exam, you've practiced the first part of the class and the middle part of the class so many times, that'll be just part of you. That'll just be who you are. And so it really will be the new stuff that will be the challenging part on the final exam. Now, class participation will be measured with the clickers, and in this class, an old style clicker is fine. We're never going to need to use the capabilities of an iClicker 2. But either one's okay. I mean, if you've got an iClicker 2, that works too. That works well. Every lecture will use our clickers, and I won't give different amount of points for the right answer than the wrong answer. Remember, many of the questions that I'm going to be asking, I know many of you have a misconception about. I know many of you are going to get the wrong answer. And so I'm not going to penalize you for getting the wrong answer. But at the end of the semester, I'm going to record how many times you clicked relative to how many times you were supposed to have clicked. And that will determine what portion of this 5% of your grade you'll be awarded. Now, I can tell you how to register your clickers right now, actually. No. There we go. If you go to the main page, there's a link that says register your iClicker right here. If you click there, it'll take you to a place where you can register your iClicker. You only have to do that before the last day of class. If you do that before the last day of class, all the points you've accumulated over the semester will come showering down upon your head. So you just as well do it tomorrow. 3, don't need to wait. Okay. I'm going to get there. There we go. Let's use our clickers. Get your clicker out. Answer this question. I thought the $43 clicker price was too high, just fine, too low. Folks, if you don't have a clicker today, that's fine. I'm not going to actually record your clicker votes for a grade until next Wednesday. So you've got today and Friday freebie. If you don't have it, that's fine. Okay. Most of you thought that was too expensive. Okay. The grade, each of the midterms will be worth 15% of your grade. The final's worth a little bit more than that, 20%. The tutorial homework, the tutorial itself is worth one midterm, 15%. 10% of that is the homework, 5% is attendance, okay? And the lecture participation, that's a clicker score. The homework that you turn in on the index cards, the 5x7 index cards, all together, there'll be about 34 of those assignments, and they will count as one midterm altogether. That gives us 100%. Now the grading scheme that I use, because we have pre-meds in here, I try to have about a third of the students get an A or an A minus. And I found that that works best if I have a cutoff for an A minus at 85. Now here's the deal. D2L is very rigid. I mean, it's got this color coding that thinks that 90 and above is A and 80 and above is a B and so forth. You just have to ignore the color coding on D2L. Don't let that upset you. The actual breakdown that we're going to use is found on the back of that yellow sheet. If you look on the back of that yellow sheet, you'll see this chart right there, and it will tell you what you need to get to earn a particular grade. Okay, office hours. Monday, Wednesday, and Friday, I will always be in my office before my first class from 10 to 11. But more importantly, I've got Tuesdays and Thursdays pretty much wide open. I teach a lot on Monday, Wednesday, and Friday, but Tuesday and Thursday I train my teaching staff. So if I'm in my office, just come on in. You're always welcome. I teach 1/3 of the student credit hours in this department. Okay? And that's because I love to teach. Now, most of my colleagues in this department, they have a lot of research and they teach one class with 8 students in it. Okay? Because they love research. And we've got an arrangement where I do my thing and they do their thing and everybody's happy. My research is working on textbooks. Okay, I have a textbook for the 103 class. We have a textbook for the 205, 207 that's coming out next fall. And that's what we call my research. What I'm trying to say with this is, I'm not here teaching because I have to. I'm amazed every month that they pay me to do this. I like doing this. I come down to this lecture hall with a smile on my face. So if you've got a question, come on in. I'd love to see you and talk about it. Okay? Now, there's also other resources. The Help Center will open next week. I'll give you the schedule when it arrives to me. You can go to your TAs. They'll have office hours. And then Smarty Cats has a program where they will provide very cheap or sometimes free tutoring. Now, if you bring me a list of the tutors at Smarty Cats, I can tell you which ones I trust and have worked with. Okay, remaining issues. Cheating. Not a problem. You people don't cheat. You're good people. And it's not your fault. It's your parents' fault. Okay, you were raised right. I learned this 23 years ago, my first semester teaching there. We give our exams at night, and as soon as you're done taking the exam, we start grading. And back then, we would grade until 2 in the morning to get those tests ready for the next day, so we could hand them back. Now, that first exam that we graded, we were so tired by the time we added up the score, we made some mistakes. I handed it back to the students and some people complained, "Hey, you gave me the wrong score." This one student, I'll never forget her name was Elizabeth Lyons. She came up to me at the beginning of the class and said, "You gave me 10 points too many." I've never had that happen to me before. And so I just said, "Well, we made the mistake, you keep the points." She went and she sat down. For 50 minutes I went over the exam, I reviewed the exam. At the end of the 50 minutes she came up to me with tears streaming down her face and she said, "I didn't earn those points. I can't keep them." That was the moment I fell in love with Montana. That was the moment I decided I'm going to be buried here in Bozeman. Because I just love you guys. And it's happened every semester that I've worked here. We should be more careful when we add up our points. But you're good people. Now, absences. If you can't go to your tutorial, you can go to another tutorial. Not every week, but if you've got a conflict one week, you could go for that 1 week to a different tutorial. We've got them all week long from Tuesday noon to Friday morning. If you have to be gone the whole week, like to a wedding or a funeral or a conference, then what I'd like you to do is fill out this absence form that you can get at the D2L site, explaining why you have to miss tutorial. If it's a valid excuse, that will give you your tutorial attendance points back, the 5 points back. You still have to do the homework and turn it in with everyone else, but you'll be excused from the attendance. It's 10 minutes after class starts. You're out in the hall. You were talking to a friend and you lost track of time. Do you come in or do you go back to the sub? You come in. This is where you belong. If you're late, okay, we'll deal with it. It's better that you're here than not here. And talking is a good thing. This is going to be a rowdy place where usually we're interacting with our neighbor. Getting help. As I've said before, everything that we do builds on what we did. And if you get lost, don't just assume that you're going to get found. Once you get lost in physics, it feels like you're being dragged behind a very fast bus. And you have to get help to get back on that bus. You need to come to me, you need to go to your lab TA, you need to go to the help center, you need to go to someone. Because otherwise you're just going to keep being dragged until you drop out. Don't let that happen to you. Now, really quick, I'm going to brag a little bit. This question, a large truck collides head-on with a small compact car. During the collision, A, the truck exerts a greater amount of force on the car than the car exerts on the truck. B, the car exerts a greater amount of force on the truck than the truck exerts on the car. C, the truck exerts the same amount of force on the car as the car exerts on the truck. Think of what you would answer there. Now do this one. An elevator is being lifted up an elevator shaft by a steel cable. The elevator is going up the shaft at constant velocity. The upward force on the elevator by the cable is greater than, equal to, or less than the weight force of the elevator shaft. Think how you would answer that one. These two questions are 2 of 30 questions on the force concept inventory. The nastiest multiple choice question test ever created. This was created by David Hessenes and his research group down in Arizona. What they did is they did interviews with hundreds of students and they found the most common wrong ideas. And they used those common wrong ideas as the distractors. Each question has 5 possible answers, A, B, C, D, and E. If you blindfold yourself and you just randomly choose, you should get 20%. What happens is if you take the blindfold off, your grade goes down. because the wrong answers are so tempting. Now, what they found across the nation was that lecture classes like this one have absolutely no impact on your score on this exam. Students at the beginning of the class and the end of the class have almost identical scores. We gave this test on the first day of class and the last day of class many years in a row. And as you can see, we made an improvement. We have some of the highest gains recorded in the nation on this exam. Now, when my friend Jeff Adams joined the faculty 8 years after I did, he said, why don't we go back and see if they still understand the physics? Why don't we invite some of these students to come back 3.5 years later and give them the same exam? We won't tell them that it's the same exam. We tell them that it's going to be a survey. Well, there's the first day of class, the last day of class, and 3.5 years later. Once you learn to ride this bike, you won't forget. That's my promise to you. Now, we're out of time. I'm going to hand out a math quiz. You're going to take it at home. You're not going to turn it into me. This math quiz is to help you decide whether you should stay in the class or whether you should drop the class. People who fail 205 fail because they don't have the proper math skills. On Friday, at the beginning of class, I'll go over these problems. If you get them right, you should stay in the class. If you get some of them wrong, but you understand how I solved them, you should stay in the class. If I work through these problems and you have no idea what I'm doing, you need to run, don't walk, and drop this class. Okay? So once you get your copy of the math quiz, you're free to go. We'll see you on Friday.